Ideal OPAMP characteristics. OPAMP is 3-terminal amplifier. Two input terminals, one output terminal, and open loop gain is A. And this output is A V1 minus V2. This V1 is in phase with output voltage. So this terminal is called non-inverting terminal. And this V2 voltage is 180 degree out of phase because of this minus sign, 180 degree out of phase with output. This terminal is called inverting terminal. So OPAMP has non-inverting terminal, inverting terminal, and output. Apart from these two, here we have supply voltages, plus VCC and minus VCC. And the transfer characteristics of this OPAMP, V0 versus V1 minus V2 or input voltage, looks like this. This is linear region. This voltage is plus saturation voltage, and this voltage is minus saturation voltage. The gain here is, or the slope is A. It means the output of OPAMP cannot go beyond the plus Vset and minus Vset. It cannot go above plus Vset and it cannot go below minus Vset. And most of the time this plus Vset is the positive supply voltage and minus saturation voltage is negative supply voltage. Now we can draw the linear model for this OPAMP. As we know that this OPAMP is voltage controlled voltage source. So the linear model is input resistance, and the amplified voltage AV in, and the output resistance. This voltage is V in, which is V1 minus V2. So this is the linear model for OPAMP. 3 terminals, non-inverting terminals, inverting terminal, and the output voltage. I have not shown the supply voltage for the simplicity of this circuit. Now for ideal OPAMP, this output resistance is 0. See, if this output resistance is 0 or short circuited, then we can directly write output voltage as AV in. V0 is AV in. And what is V in? V in is V1 minus V2. Voltage at non-inverting terminal minus voltage at inverting terminal. Now the second condition is that the input current at both the input terminals are 0. IB1 is 0 and this IB2 is also 0. Now these two currents are 0 if and only if the input resistance is infinite. So for ideal op-amp, input resistance is infinite. This will make the input currents 0. IB1, IB2 both are 0. Now we have seen that output voltage is nothing but the amplified input voltage, and input voltage is nothing but the difference of voltages. So op-amp basically amplifies the difference of input voltages. Okay, so op-amp basically rejects the common part of the two input voltages. So in ideal op-amp, the common mode gain is 0. In other words, common mode rejection is infinite. Now the next condition is bandwidth. See, the voltage gain of op-amp is constant for all frequencies. For low frequency, for high frequency, for any frequency, the gain of op-amp, open loop gain of op-amp is constant. It means the bandwidth of op-amp is infinite. Bandwidth is infinite. This is for ideal op-amp. Now the next case, the voltage gain, the open loop voltage gain for ideal op-amp is also infinite. This A is infinite. Open loop voltage gain is infinite. If the open loop voltage gain is infinite, then for ideal op-amp, this slope also becomes infinite. So this will change the transfer characteristics of ideal op-amp. If the difference of input voltage is positive, then output voltage is plus Vset, and if the difference between input voltage is negative, then output voltage is minus Vset. The difference between input voltage is means voltage at non-inverting terminal minus voltage at inverting terminal. Now if voltage gain, open loop voltage gain of ideal op-amp is infinite, then we will have one more condition, and it is called virtual short condition. See, because V0 is A, V1 minus V2, we can write V1 minus V2 as V0 by A, and if A is tending towards infinite, then V0 by A is tending towards 0. So in other words, if A is infinite, voltage gain is infinite, then V0 by A is 0, or V1 minus V2 is 0, or V1 is V2. It means voltage at non-inverting terminal must be equal to voltage at inverting terminal when the open loop gain of ideal op-amp is infinite. This condition is called virtual short condition. See, since the voltage gain of op-amp is infinite, ideal op-amp is never used in open loop condition. We always use OPAMP, ideal OPAMP with negative feedback to make the gain of OPAMP finite.